Welcome to this explainer. Today, we're fundamentally shifting how you look at artificial intelligence. It's time to stop seeing AI as just a magic text box that writes poems or answers trivia. Instead, we're going to start viewing it as a highly structured, goal-directed software engineering system. If you want to understand how the actual next generation of AI is being built right now, you are in exactly the right place. Here's our roadmap for today's explainer. We'll cover the paradigm shift, the anatomy of an agent, the orchestrator loop, the engineering process behind it all, guardrails and safety, and finally, separating myths from reality. Let's dive right in. Section 1. The paradigm shift. So, understanding this behavioral shift is absolutely crucial. You know how a standard chatbot works, right? You ask a question, the model replies once, and boom, the interaction is over. But an AI agent? Totally different beast. You give it a high-level goal, and it actually creates a plan. It calls external tools to gather information, checks the results of those tools, updates its plan, and just keeps iterating until that final goal is actually achieved. When you look at them side by side, the difference is night and day. On one side, you've got that linear, one-and-done chatbot. But on the other, it's clear an AI agent isn't just a language model. It's an LLM that's been securely placed inside a highly controlled decision and action loop. The reasoning engine is right there in the middle, but it's constantly acting, observing, and iterating over time. Section 2, Anatomy of an Agent. Now, what's really fascinating here is realizing that the large language model isn't the whole shebang. It simply acts as the reasoning engine. Sure, it's the brain, but it's completely surrounded by vital infrastructure. The prompts defining its rules, the tools it uses to interact with the outside world, the state memory keeping track of what it's up to, and the evaluation mechanisms verifying its decisions. To manage all these moving parts, the tools, the memory, the reasoning engine, we absolutely need an orchestrator. You can think of the orchestrator as the critical software program wrapping the LLM. It's essentially the traffic controller for the entire system, guaranteeing the agent actually follows instructions and doesn't just run amok. This orchestrator code is the central hub of it all. It dictates exactly which model to call and what specific prompt to send. It defines what tools are currently available to the agent, how to handle unexpected errors, how many steps are permitted, and exactly when it needs to stop. Without this traffic controller, the LLM is literally just generating text into the void. Moving on to Section 3, the orchestrator loop. The foundation of all this agentic behavior is actually a remarkably simple four-step process. First, observe the environment. Second, think about the current state of the task. Third, act using the available tools. And fourth, loop through that process over and over until the goal is complete and it's time to stop. Underneath those simple steps is a very formal mathematical heartbeat. At any given moment, the agent updates what it knows, its current state, then it chooses an action based on a specific policy and its overall goal. Finally, the environment kicks back an observation based on that action, and the whole cycle repeats. It's a precise, highly managed cycle, not just a random generation of words. Section 4, the engineering process. Now in engineering phase 1, everything revolves around the principle of least privilege. We absolutely want to avoid giving the agent broad, sweeping execution power, like allowing it to just run any code it wants. Instead, we give the agent the absolute smallest, narrowest tool that can get the job done. If it just needs to do math, give it a specific calculator tool, not open-ended access to your computer's terminal. This drastically cuts down on excessive agency risks. Which brings us to phase 2, core logic and memory. Here, the orchestrator leverages precise state tracking to prevent infinite loops, because, we don't want an agent getting stuck asking the same question forever. We also have to be super careful managing short-term and long-term memory architecture. If you carelessly store too much memory, you risk the agent using outdated information or, even worse, accidentally exposing private user data. To really make this concrete, let's look under the hood of a chemistry study planner. A regular, weak chatbot would just instantly guess a generic schedule, but our agent, it uses tools to calculate its internal state first. In step 1, it actually notices missing information and asks the user, hey, what are your weak topics and available days? By step 3, it updates its internal state variables, knowing there are 4 hours available and the user struggles with equilibrium. Only then does it execute a tool to generate a realistic, personalized plan. It's actively managing a complex task over time. Section 5, Guardrails and Safety. Okay, here is a massive revelation for a lot of people. Prompt-based rules, like just telling the model, hey, be safe, are simply not enough. Robust agents require hard, software-level filters before they ever get to interact with the external environment. Every single action an agent takes must pass through a strict filter before it hits an API or a user. These software checks, they are non-negotiable for responsible agent design. You literally must require user confirmation before an agent sends an email. You've got to check permissions before accessing private data. You route any executed code straight to a safe sandbox. And you have to implement hard budget limits to stop an agent from racking up thousands of expensive API calls if it gets confused and loops out of control. Believe me, your wallet will thank you. These checks ensure the system respects its boundaries, completely regardless of whatever the LLM might try to generate. Section 6, Myths versus Reality. Let's separate the hype from reality here. Myth: more autonomy is always better. Reality: more autonomy actually equals more risk. You should always aim for the absolute minimum autonomy needed. Myth: if a model can reason well, it doesn't need tools. Reality check: models make math and factual errors constantly. Tools are absolutely necessary to check the outside world. And as we just talked about, prompting alone cannot make an agent safe against malicious injection attacks. Real safety demands hard, software-level constraints. So when you zoom all the way out, you really see the whole system coming together. You've got the goals, the tool APIs, the guardrails, the memory stores, the evaluation benchmarks, and all of it orbits that central orchestrator software, which carefully manages that whole observe, think, act loop. This is a complete, rigorous engineering discipline. It's not just some casual wrapper slapped around an LLM. If there's one thing I want you to take away from this explainer, it's this. We aren't just trying to make a large language model inherently smarter or more magical. It's the engineering discipline of designing a responsible, tool-using software system around that model. We are literally turning a text generator into a goal-directed engine. I'll leave you with this final thought. As we start deploying increasingly powerful AI into our everyday workflows, are you going to rely on a magic text box and just hope it doesn't hallucinate? Or are we going to take responsibility to actually engineer constrained, safe systems with strict boundaries? The future of reliable AI is built through rigorous engineering, not blind trust. Thanks so much for joining me on this explainer, and I'll catch you next time.